Hello and welcome, my dear students. How are all of you? This is Ms. Ruchika welcoming you to her session on her channel Mathematics Made Easy. So today we are on day 3 of our session of trigonometry. 10 days of trigonometry are still in progress. I hope you are enjoying my videos and finding them useful. So we are going to be relating to our real life examples in these sessions, and today we have an example of a word problem which is coming all the way from London. So we are going to talk about London Eye, the famous London Eye, and we're also going to talk about what is the trigonometry behind it. So without talking much now, let's get into the video. In continuation to our real life applications of the topic of trigonometry, we are going to be doing another interesting word problem. So let's dive into the video and see what is the problem for today. So before we get to know the interesting problem for today, I'm here with you to show you the famous London Eye. So this ride, as you can see, is like a giant wheel, and I'm going to show you some trigonometry related to the London Eye. Interested already? So let's dive in and get to know what is the trigonometry behind the moving of the giant wheel, the London Eye. I'm sure most of my students which are there in Dubai can now relate to the in Dubai or the in Eye, which is quite close to the London Eye, and currently it is not running, it is under maintenance, but yes, inshallah it will run soon, and I'm sure most of you must have already taken a ride there. So let's see. So the next time you are going to plan to sit in a giant wheel or in Dubai or any other giant wheel ride, look at the trigonometry, just see what angles it is moving through, how the rotations are going, how the circumference, rotation, angles, all of that is related. So let's see what is the trigonometry behind this London Eye. Okay, so another word problem, let's read it together. So your London Eye is told is a giant wheel. It's like a Ferris wheel. So the London Eye is one of the world's largest Ferris wheels. It's quite true. And the diameter of the wheel is given to you. Let's highlight that information. 135 meters. Okay, next is what? And it is making a complete rotation. So one rotation of the London Eye ride is taking 30 minutes to complete. Now, a passenger gets onto the ride and travels for 5 minutes before the ride stops. Okay, so he gets on the ride and he travels for 5 minutes before the ride is coming to a halt, before the wheel is stopping. So the passenger wants to know how far she traveled during this time. So we want to find that distance, and because it is trigonometry, we're talking about angles, so definitely that will also be considered. In part A of the question, it asks during the 5-minute interval, what is the measure of the central angle? Now, because your London Eye is like in the shape of a circle, it's moving through a central angle. So how much rotation it went through in those 5 minutes, how much was the measure of the central angle, that's what you need to find in this part. And as you see, it is given to you that you need to give it in radians, so that is the unit that you will be looking. So this is our day 3 of trigonometry, problem number 3. So this beautiful picture I've taken for the London Eye, just to show you how beautiful it is. I'm sure you all agree to that. Okay, so let's solve the first part, A part. In this one, you are given that the 5-minute interval that the person is on the London Eye. What is the measure of the central angle of the wheel's rotation, and the unit is radians. So in the question, when we had highlighted in the previous slide, you had seen that one rotation is taking 30 minutes. So let's write it. One rotation takes 30 minutes. So now you need to see in 5 minutes how much part of the rotation you are taking. So you don't know, take it as x, and then you cross multiply and find that x. So 5 will multiply with 1 to give the same thing, x will multiply with 30. So in order to get this x, you divide 5 with 30. So what is this fraction? 1 divided by 6. So 1/6 of the complete rotation is been taken in this 5-minute interval by the wheel in a wheel of the London Eye. Okay, so that's the fraction that you got. Now you need to give for a part in the rotation in terms of angle. So what is the complete rotation? It is in terms of degrees, 360 degrees by the angle, and 2 pi radians for the angle. So you are asked here in radians, so we'll take 2 pi. So what is the 1/6 fraction of 2 pi? That is going to be your answer. That is pi by 3. And what is the unit? Radians. Okay, so that's A part. Let's do B part. Explain how to find the distance the passenger traveled to the nearest meter. That's the next thing. So in B part, you need to find the distance, and because we are talking about circles, because we are talking about angles, we are going to find the arc length. Okay, so formula, I hope you remember, S equal to R theta. R is the radius, theta is the angle. Now angle already you have found in part A, which is pi by 3 radians. And let's now find radius. So what was given to you in the question? Let's come back. Diameter. So if diameter of a circle is given, how do you find the radius? Yes, very good. You get the radius by dividing the diameter with 2. So what is that? 67.5. So just put R at 67.5. Theta as pi by 3 radians. You got from first part, substitute, simplify, and you get your answer. So here around the nearest meter, you round it off and you get your distance the passenger traveled to the nearest meter is around 71 meters. So that completes part B. Next is part C, where you need to just justify and check your answer. So explain how you know your answer is reasonable. So we have to see whether B part, the answer that you got 71, is reasonable or not. So in order to do that, you will just use the simple formula for circumference. So what is circumference? Circumference, the formula is either 2 pi r, or if you want to say in terms of diameter, it will be pi d. So it is the total distance covered. So if you have a circle like this, its boundary is circumference. So for London Eye, the boundary of all the seats, if you join them, it is like the circumference. So this is the formula. Pi d, pi is 3.14, diameter is given to you, so this comes about roughly 423.9. Now in part number B, you had found the distance the passenger traveled to the nearest meter, and you had got in part A the fraction as 1 by 6. So you divide this total circumference. See, you need to understand this. This is an important point. So this is the total circumference of the circle, right? The boundary. That came how much? 423.9 meters. Now you need to know just in that 5-minute interval. So this is center C, this is angle theta. So how much is this distance? Only this one now you are asked. So this is how much? 1/6. That's the fraction you got in part A of the question. So you divide 1 by 6, you multiply with 423.9, or you divide by 6, same thing. So that is 70.65, which is near about very close to 71. So that means part B, that what calculation for the length we had done was correct. So the answer is justified. It is quite reasonable. So that completes the question. Hope it was clear to you. If you have any questions and queries, please put it in the comment section. I'll be more than happy to help you. That brings us to the end of day 3. Thank you for watching. This concludes our session for today, the video for today, which was on 10 days of trigonometry. Stay glued to my channel for another interesting video, which is going to be coming tomorrow for day 4 of 10 days of trigonometry. Make sure you like, subscribe, and share this video if you are liking it, and let me know your comments and questions, queries, and concerns in the comment section. Till then, this is Ms. Ruchika signing off from the session today. Bye, students.